Okay, welcome to your Unit 2 test review. Go ahead and have your notebook and pen and pencil or whatever you have, and let's get started here right away. I'm going to start by giving you some examples of some of the items you'll be seeing, and just go ahead and sit back and watch. We'll go through this together real quickly, and then I'll give you a couple to practice on your own. Let me grab my pen here, and let's see what we got. Here I've got a monomial times a monomial, so let's not get too crazy here. Let's just take this 3 and multiply it by -4. We know that's -12. And how many n's do you see here? Well, I see 3 here and 4 here for a total of 7. So it looks like we should have -12 into the 7th. And let's check our answer here. And sure enough, that's what we got. All right, here's a couple more that are very similar to that. So take that idea of just multiplying the coefficients and adding those exponents together. And once you solve those, and I'll wait right here till you're done. Okay then, let's see. Let's take a look at our first one here. You've got 3x cubed y squared times -5xy. Well, we know that we're going to end up with another negative answer because of the positive and negative. And let's see what you got. Hopefully you got -15x to the 4th y cubed. And how about the bottom one here? Let's check your answer on that one and take a look at that. If you didn't get those, go back and double check. Make sure that you counted up the letters properly, you multiplied the coefficients. And if you're not sure, make sure you bring that to class when we see each other next time. All right, let's try another one. How about this? 3a squared, and the whole quantity there is going to be cubed. So what does that really mean when you have that cubic exponent there? Well, here's what it means. It really means 3a squared times 3a squared, and again 3a squared. And we know that 3 times 3 times 3 is what? What do you say? That's right, it's 27, and we have 2a's here, 2a's here, 2a's here for a total of a to the 6th, a to the 6th there. What's the faster way to do that? Well, 3 cubed is 27, and 2 times 3 is 6, and we can just jump ahead here. Let me check our work, and sure enough, there we are, 27 a to the 6th. Here's a couple to practice that are very similar, so take a look at those. I had a cubic, and you guys have some squares there. And go ahead and press pause, do those, and come right back. All right, let's check your answers here. On your squared, your first factor there with the -4x cubed y to the 4th quantity squared, did you end up with 16x to the 6th y to the 8th? Where do those exponents come from? Remember, you're just a power to a power. We're just multiplying the exponent to each other. How about the bottom one? Did you end up with 9 into the 6th m squared? Let's hope so. If not, double check that. Go back and look at the example we did and see what you think about that. All right, let's try another. How about this one? We have kind of a spooky looking one here. We've got a fraction with a negative exponent and some stuff jumping out at you there. Try to focus on the numbers first. So how about 10 over 5? Well, we know 10 over 5 is just an easy answer. 10 divided by 5 is now and always has been the number 2, so we're going to grab a 2 here. But what about this x to the 4th, x to the -2? Remember that we don't really want to work with negative exponents. That's not going to be something you see and can actually live with for quite a long time. We're always going to make these exponents here positive. So if this guy is essentially unhappy in the denominator spot, let's go ahead and grab those 2 x's and move them up to the top, and then they'll just magically become positive. It has to do with multiplying by the reciprocal and so on, but just the short of it is, if they're unhappy at the bottom, move them to the top, and vice versa. So you're looking at 2x to the 6th, 4, and then add those 2 there. Let's go ahead and check here, and sure enough, that's what we got. Here's a couple more. Give those a try on your own. Write them down in your notebook there, and let's see how you did. Okay, here you've got 40x to the 5th over 8x to the -3. If we just ignore the x's and divide 40 divided by 8, well, we know 40 divided by 8 is going to be 5. And did you take those negative, or we could say unhappy x's, and just move them to the top? So you should have 5x to the 8th. Now how about this kind of messy looking one here? You've got 4 over 2. Well, we know that's pretty simple. That's just going to be the number 2. Did you move the a's here on the top to the bottom, and the c's on the bottom to the top? And what about those letters b there? B to the 3rd over b to the 3rd, well, those cancel. So you get a nice easy answer of 2c cubed over a cubed. Even though c and a are cubed, they're obviously different numbers because they're different letters. So they represent different numbers. So no reducing there. Just leave it 2c cubed over a cubed. All right then, let's go ahead and turn the page to the next type of problem. Here we're going to do some binomials. Now, here you've got 4n plus m quantity squared. So let me go ahead and grab this pen here for you and let's get to work. So right here, I'm going to go ahead and draw a nice, maybe not so pretty, but it'll be effective, a 2x2 box right here, 2x2 box. Change the colors here so we can see what we got. I've got 4n plus m here, 4n plus m here. And let's start filling this in here real quick, just like back when we did multiplication tables. How about 16n squared, 4nm. I'm just multiplying 4n times m here. The same two factors there. So I got that. And what is m times m? Well, we know that's going to be m squared. Now right here, remember that this guy at your first box that you filled in is going to be part of your answer, so 16n squared. And we know this guy is part of your answer, m squared. And what do we do with these two pieces in the middle? Well, those are like terms, so we combine them. And our final result is 8nm. And that's a positive m squared there. So here's your final result right here. And if you recall, we talked about it in most classes, if you have this arrangement, this is what we call a perfect square trinomial. Square the first, there's your square of the first. Square the second, there's your square of the second. Multiply these two together times 2, and there's your 8nm. All right. So if you can see the shortcut, a little bit faster. If not, use the box, and you're still good to go. The box will always be there for you, and you'll get the problem correct. All right. How about these two? Check these two out. Go ahead. If you can see the pattern, go ahead and use it. Try it out. See what you get. You can also double check it by using the box. If not, just use the 2x2 box. Get yourself a right answer, and I'll be waiting here when you get back. All right then, I've got a minus b quantity squared. Did you end up with a squared minus 2ab plus b squared? Okay, a 2x2 box will show you that that's going to be the case. And how about the bottom one here? A little bit messy, but I think if you look at the top, you could probably almost get this. 3c squared, well, you're going to have 9c squared at the bottom, 16d squared here. What goes in the middle? How about that right there? So you get that nice, healthy looking trinomial. So don't be intimidated by these. Just use a 2x2 box and it'll all work out nicely. All right then, how about this one? Now this is just, looks like I've got a couple of binomials. We're going to do some subtraction. We know that with algebra, we'd really rather not use the operation subtraction. So I'm going to leave the first binomial here alone, but I am going to change the second one. I'm going to change this to addition. Now what's the trade-off? Remember when we had algebra tiles, we took those and we flipped those tiles upside down. So I'm going to take this and I'm going to change this to negative, and I'm going to change this to adding 2y. And now we can just go to work. 4x squared plus negative 2x squared, well that's going to be 2x squared, right? 4 and a negative 2. And how about a positive y and a positive 2y gives us positive 3y. Let's go ahead and check our work here and see how we did. There we are, 2x squared plus 3y. Now here's a couple others. Now these are trinomials. It's the same thing. Just line up those like terms. Make sure that you switch to addition and change the signs inside the subtrahend. That's a fancy word for the second polynomial there. All right, give those a try, and I'll be waiting right here. Okay, here we go then. Let's go ahead and check that. Make sure of course you're pressing pause, you're doing your work, and you come right back, and we'll get right back together here and see what we got. Did you end up with 3n squared plus 4n minus 7? I hope so. Remember, if you change this to addition, all these signs get flipped around, and we end up with a negative 1 here. Negative 6 and negative 1 gives you negative 7 for the constant here. And how about the bottom one? C squared plus 2c plus 11. So check those out, and let's see how you did there. All right, got a couple more here. How about this one? Here's just a classic old 2x2. I think we can do this really quickly with a box. We can just draw a 2x2 box here like this, and some of us may be at the point where we can start seeing these answers before we actually finish. X plus 3 x plus 4, and just go ahead and fill this box in, x squared, 4x, 3x, and of course positive 12. What do we do with those middle terms there? Well, we're going to add those two guys, right? So we end up with x squared plus 7x plus 12. And some of you might start seeing the relationship between the number 7, well there's your 3 and a 4, and the number 12, there's 4 and 3 multiplied together, right? So I'll let you put those pieces together on your own, but we can always use the box and get the correct answer there. Give these a try. We've got one that's a traditional n minus 4 times n minus 2, and one kind of is a throwback to a few slides ago with that perfect square trinomial. See what you can do, and let's check our answers in just a minute. All right then, n minus 4 times n minus 2, I'm kind of bet we're going to have some kind of negative 6 in there and maybe a positive 8 if we do some adding and multiplying in the right way. So there you go, n squared minus 6n plus 8. And how about this one? Here I'm looking at an a squared, a positive 25, and what about that middle term? Well, how about a negative 5a times 2? And there you go. A squared minus 10a plus 25 would finish that one off nicely. All right, let's go ahead and move forward here and take a look at this one. Now, this is a nice, scary looking problem here with our 2 by 3, but we're pretty good at 2 by 3s. We did lots of these in class together, and I saw you working on these during our practice tests and so on. So let's make a 2 by 3 box. I'll change the color here so we can get to work. How about x plus 2 goes here? We're going to use that binomial, of course, down the side with 2. And how about x squared minus 5x plus 4? Now, if we just start filling this in, x times x squared, well, that's going to be x cubed, of course. X times negative 5x, how about negative 5x squared? And x times 4, 4x. That takes care of the top row there. How about the bottom one? What's 2 times x squared? Well, that's 2x squared. 2 times negative 5x, negative 10x, and 2 times 4 is 8. Now we're looking for things that, of course, are part of the solution and also can be combined. I don't see anybody that's going to work with x cubed, so he's going to be part of our answer. These two here can be added together, which will give us a negative 3x squared. These two here added together, which give us a negative 6x. And this guy's on his own here with positive 8. So there's your final solution. X cubed minus 3x squared minus 6x plus 8. The answer looks kind of intimidating, but if you use that structure of the box, fill it in, combine like terms, nothing to it. All right, let's double check and make sure that's what we should have had. I think that looks right. And here's one for you. I didn't give you 2 of them here because those take a little bit of time. So just practice that one and come right back and we'll see how you did. All right, very good. Let's see how you did here with your 2 by 3 box. We know we're going to have an x cubed. Looks like we're going to have some kind of positive 30 at the end. And there's your complete polynomial, x cubed minus x squared minus 26x plus 30. All right. Again, go back and double check if you're not sure how this, if you got something wrong. Maybe you redo it. Try it again. Bring your question to class if not. Okay, got a couple more here. Well, this says find the perimeter. They'll always have this little default figure not drawn to scale. That'll be on your testing and in the formal book, so I just threw it in there. It just means that if you got out a ruler and measured it, you wouldn't find that the x's match perfectly and all that. They're just throwing some numbers out to help us practice. So find the perimeter means that we're going to simply add up all the edges, yes? So if we take this here, if we know that this side's x plus 5, this side's x plus 5, if this is 2x plus 3, this is 2x plus 3, and then what do we do with our x's and numbers? Well, as you know, we're going to add up our x's, and we're going to find a sum of them. So 2 and 2 is 4, plus 1 is 5, plus 1 is 6. So I got 6x there. 5 and 5 is 10. 3 and 3 is 6. So maybe 10 plus 6 is 16. So I think our perimeter is going to be 6x plus 16 here. Perimeter is different than area. Area, of course, if we were asked to find, if this said find the area, well, to find the area, we would multiply this guy by this guy, and that would bring us back to a 2 by 2 box, yes? So area, then, we would multiply length and width, just like any other rectangle. But in this case, let's check our perimeter. Looks like our perimeter is indeed 6x plus 16. Now, how about this one? Of course, I got the easy one, didn't I? I'm going to leave you there with a little bit more challenging one. Go ahead and give that a try. Count those x's and numbers, and let's see what you got. Okay, take a look. Here's what I got when I did all these numbers. Remember, you're adding up the x's. You got some zeros in there, a negative 11, some positive 3's, and I got 14x minus 5. I hope you got the same. Alright then, here's our last one. It says, Hank is extending the fence around his rectangular yard that has a width of x and a side length of x plus 8. If he extends the width and length by 4, what's the new perimeter of the fence? So, first thing we're going to do here is I'm going to go ahead and just sketch out a rectangle. And I'm going to say that the width is x and the length is x plus 8. And if I extend this out, I'm going to go ahead and add 4 to both the width and the length, and then let's just go ahead and grab a perimeter here. X plus 12, x plus 4, of course, they're going to mirror each other on the opposite sides, and we should end up with 4x plus 32. X and x and x and x is 4x, and then we got 2 sets of 16 there. Alright, practice this one, and we'll give you an answer. It says Ann wants a fence built around a rectangular swimming pool that is 8 feet from each side of the pool. The pool has a width of x plus 1 and a length of 3x plus 2. Find the perimeter of this fence. Alright, so I'll give you a minute or two there. Well, heck, you can take as long as you want. Just press pause, and I'm not going anywhere. Alright then, so my first question to you is, did you quickly sketch a rectangle? As soon as you saw that word rectangular swimming pool, make sure you sketch that rectangle, drop down the information given to you, which was x plus 1 and 3x plus 2. That's where you start. Then move on to the next piece, which is we're going to extend each of these lengths here and width by 8. So this x plus 1 then becomes x plus 9. And this 3x plus 2, we're going to go ahead and grab that to be 3x plus 10. Just mirror the same across from both sides. If this is x plus 9, so is this. 3x plus 10, so is this. And I'm getting a perimeter of 8x plus 38. Alright then, well that's the extent of your Unit 2 test review. Feel free to practice as much as you possibly can. Don't be afraid to go back and look at some previous videos as you need to. And please be ready for your unit test. You know that those are heavily weighted for your grade, and we just want to make sure that everyone comes out smiles there. Here's some recommended. We have some practice tests there at ors.net/Menifee. Alright then, have a good time, and I'll see you soon.